Have a few review problems here to kind of supplement what you'll find on your review worksheet. So the first one says, for what value of k is f of x continuous at x equals 1, and we're given a piecewise function. So at x equals 1 is where these two pieces may or may not come together. So if all I asked was what you see in the white, it would be fine to plug 1 into the left-hand branch. That's the function to the left of 1, and that would be 1 squared plus k times 1. And then we could set that equal to the right-hand branch, what we get as we approach 1 from the right. And so that would be 5 e to the 0 plus cosine of, it's going to be 5 pi. And so that's going to be k plus 1 on the left. We're going to solve this for k. E to the 0 is 1. That makes that 5. Let's see, cosine of 5 pi. I have to think about the unit circle. So cosine is going to be 1 at 0, negative 1 at pi, 2 pi, 3 pi, 4 pi, 5 pi puts us back here. And that's going to be a negative 1. And so k is going to be 4 minus 1 is 3. Now, if I ask you to justify it, that kind of ups the standard a little bit here. So if you remember, there are three things that must be true for a function to be continuous. The limit as x approaches c must exist, and the value of the function must exist, and the limit must equal the value of the function. So sometimes this can be kind of condensed into just that third step, that the limit as x approaches c of f of x must equal the value of the function at c. That kind of implies that they both exist. So we could say that our left-hand limit is going to be this piece right here. That's going to be k plus 1. And the right-hand limit is going to be this part right here, which is going to be the 5 minus 1. And the value of the function at 1 is going to be the same as the left-hand part there, because that's where the or equal to lies. So we could then say that the left-hand limit equals the right-hand limit is equal to f of 1. So this is what you have to communicate, is that you understand that definition of the limit. And then we can go right back up to where we are there. So this is the piece that you need to have additionally to get the justification credit. Okay, here's taking us back to some trig. We have secant squared minus 2 equals 0. I'm going to say secant squared x equals 2, square root both sides, and get plus or minus the square root of 2, recognizing that secant is the reciprocal of cosine. We can then take the reciprocal of both sides and get plus or minus 1 over the square root of 2, which once we rationalize it, hopefully becomes familiar. And cosine is going to be square root of 2 over 2 in quadrant 1 at pi over 4, and it will be positive or negative at each of those angles with a reference angle of pi over 4. So that's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So looking at the second one, we can factor out the greatest common factor of cotangent of x, and that's going to leave behind cotangent x plus square root of 3. So that means that cotangent x could be equal to 0, or cotangent of x could be a negative square root of 3. Since cotangent is cosine over sine, and we know that a fraction is equal to 0 when its numerator is 0, that's going to occur at the same places where cosine is equal to 0. And cosine is going to be 0 at pi over 2 and 3 pi over 2. Now let's talk about cotangent being square root of 3. So there's a couple ways of doing this. I'm going to ignore the negative sign for a moment and think of square root of cotangent as being cosine over sine. And that's going to be the same angle where cosine is square root of 3 over 2 or sine is a half. That's the same angle. Hopefully that you can recognize that our reference angle is going to be pi over 6. And if we want the cotangent to be negative, then cotangent is going to be negative in quadrants 2 and 4. And so with a reference angle of pi over 6, that will be 5 pi over 6 in quadrant 2 and 11 pi over 6 in quadrant 4. Okay, another kind of problem here, one of our favorites. This is finding f of 2 plus h minus f of 2 all over h given, and the tricky part here is we have a radical function. So f of 2 plus h means we're going to plug in 2 plus h where we see the x, and then minus, we're going to plug in the 2, and then all over h. So simplifying that is going to make that be square root of 9 plus h minus square root of 9, which is 3, all over h. And the tricky part here is to get rid of this radical. Remember, we're finished when we can somehow factor out the h and cancel it. What we're going to do here is multiply top and bottom by the conjugate of that radical numerator. So we are going to rationalize the numerator, which seems kind of weird. That's going to give us the difference of 2 squares on top. And in the denominator, I'm going to leave it factored for now, trusting that something good is going to come of all of this. So once we get to here, we can see that the 9 and the negative 9 will cancel each other out. Once they're out of the picture, we are free to cancel the h's, and as we were promised, once we finished canceling the h's, we are finished, and that's going to leave us with 1 over the square root of 9 plus h plus 3. This is just a sampling of some of maybe the trickier problems.